All right, let's pull back the curtain on a hidden conversation that's happening all around us, probably dozens of times a day, and we don't even notice. We're going to explore the tech that lets all those security devices in our world, the cameras, the door readers, actually talk to each other. Let's dive in. So picture this. You swipe your badge at work, you hear that little click as the lock opens, and somewhere a camera takes note. It feels totally seamless, almost like magic, right? But it's not magic. It's actually a pretty sophisticated digital conversation. So how in the world does a simple door reader communicate with a complex video system? That's the exact mystery we're going to unravel today. Okay, so to really get how we got to this point, we've got to take a quick look back at how things used to be connected. And, well, it all started with a simple and, frankly, not so smart wire. And wow, this really shows the huge leap we've made, right? The old way, the dumb wire, could only send a basic pulse. It was just enough to say, hey, the door opened. That's it. But with software, that conversation becomes incredibly rich. It sends what we call metadata, all this detailed context. It's not just that the door opened, it's who opened it, what their card number is, the exact time, and it even pulls up their photo. I mean, that's the difference between a blinking light and a full-blown conversation. It's about real intelligence. So, for that smarter conversation to even happen, these systems need a common language. And this brings us to the heart of it all, what we call the digital handshake. We're going to look at the two main ways this happens, through things called APIs and SDKs. Okay, first up, we have the API, which stands for Application Programming Interface. The easiest way to think about it is this. One company, the manufacturer, publishes a list of commands its system will understand. Then another system can use that published list to make very specific requests. And a lot of modern APIs use the same kind of web protocols as your internet browser, which makes them super compatible with a whole bunch of different systems. And this, right here, is the perfect way to think about it. The API is the menu. The access control system can look at the video system's menu and order one stream of video from camera 1. And the video system delivers it, no questions asked. It's a really clean, structured way for them to talk. But here's the catch. You're limited to what's on the menu. You can't ask for a custom dish. All right, so if an API is like ordering from a menu, the other approach is totally different. It's the SDK, or Software Development Kit. This is a much more hands-on way of doing things. Instead of just a menu, the manufacturer basically gives a developer a whole box of tools, pre-written code, instructions, and all the rules they need so they can build a custom solution from the ground up. Exactly. If the API is the menu, the SDK is like being handed a whole tool belt. It lets a developer build a custom button or feature that looks and feels like it was part of the original software all along. This means you can get a much deeper, more seamless integration because you're not just ordering from the menu. You're basically building a whole new station right inside the kitchen. Okay, so we know the languages, right? API and SDK. But how does a technician actually connect these things in the real world? It's not like they're writing code from scratch every time. Nope. They use these pre-built software bridges, usually called plugins or drivers. Let's see how that works. The process is actually pretty straightforward when you break it down. First, the technician installs the plugin. Simple enough. Then, they just tell it where to find the other system by punching in its network address and the login info. And then step 3, this is where the magic happens. It's the handshake. The video system logs into the access system and basically asks, hey, can you give me a list of all your doors? Finally, the technician just drags and drops front door onto lobby camera in the software to create that logical link. And boom, the systems are officially talking. All right, so we get the how now, right? We see how the connection is made. But this opens up a much bigger question about the overall philosophy behind how you design these things. And there are really two main camps here, building an integrated system or building a truly unified one. So, on one hand, you have an integrated system. Think of this as two separate brains, two databases that talk to each other using an API. The big pro here is resilience. If one system goes down, the other one keeps on chugging along. But the downside, data can get messy. Sometimes it gets out of sync. Now, a unified system, that's totally different. It's one single brain, one database for everything. The huge win? Your data is always perfectly in sync, which could be absolutely critical for, say, a high-security facility. But you can probably guess the con, right? That single database is also a single point of failure. If it goes down, everything goes down with it. Okay, now for the part that every technician lives and breathes. What happens when the talking stops? When that digital handshake fails and the systems suddenly give each other the silent treatment. Let's walk through how to figure out what went wrong. Believe it or not, when an integration breaks, it's almost always one of three usual suspects. First, the network link. Can the servers even see each other on the network? A simple ping test will tell you that. Second, the firewall. Systems talk through these specific digital channels or ports, and sometimes a firewall can block them. And third, the credentials. The systems use a special service account to log into each other, and maybe, just maybe, the password is wrong or it expired. And this right here. This brings us to the number one most important, absolutely crucial rule. If your company's IT policy forces passwords to change every 90 days, your integration is guaranteed to break, you guessed it, every 90 days. That's why the golden rule for technicians is to always set service accounts to password never expires. It is the single most common and most easily avoidable reason these things break. Seriously. So, there you have it. These digital handshakes, they're happening all around us, all the time, making our world feel a little more connected and a little smarter. But it really leaves us with a fascinating question to chew on. As we connect more and more of these systems together, are we creating a more robust and intelligent web of security? Or are we just introducing more complex and fragile points of failure? It's something to think about.